So we're looking at the central limit theorem during this video. So what we've been working with up until this point is we've been looking at what we would call the population mean and then the population standard deviation. We have a theorem that states that if our samples get large enough and sufficiently large enough, then we can get what we call a central limit theorem, where we will get a distribution which will become approximately normal as our sample size increases. So for instance, just say we had one can and it had a mean weight of 380.6 grams and a standard deviation of 3.4 grams. If we were going to look at this in terms of a distribution, what we would have here is we'd have something that kind of looks like this. However, if we start taking more and more and more samples, what happens here is this data starts taking a different form. So if we have a sample of just say about 10, we start getting all this data. But if we start getting say a sample of 100, what happens here is that our data starts coming to a mean. And they represent that same type of mean where we'll end up over time getting a normal distribution, which is normally approximated. And this is what the central limit theorem tells us, that as you take more and more samples, your distribution will become approximately more normal. So for instance, we know that if we have a population mean that looks like this, and then we have a standard deviation mean which looks like this, the sample means, when we have a lot of samples, is denoted by your means with a subscript of n, where your n is the number of samples. And what you should notice here is when you're working with these samples, so for instance, if we did 3 different types of graphs, so we have a graph where we've got a sample of, say, a sample of 5. And then we have a second graph which has a sample of 10. And then we have another graph where we have a sample of 100. What you notice is as your sample size increases, your graph becomes more approximately normal. Okay, so as n increases, the graph becomes more normal. Another thing that you notice as n increases is that your mean remains the same. Okay, so your mean is the same, but what we notice is that your standard deviation, it's decreasing as your sample size increases, which is a really important thing that we need to understand when it comes to the central limit theorem, is as n increases, the standard deviation decreases, which makes sense, because if we're increasing our sample size and the peak of your distribution curve is increasing, the standard deviation is going to be decreasing in each end. So we now have new notation that represents information that's dealing with sample means. And that would be this. So this here is your sample means, and this here is your standard deviation. Okay?
Now,
the mean is exactly as the same as your population mean, as we can see in these calculations. However, your distribution, because it's changing, it becomes a new way of calculating that. So to calculate the standard deviation of a sample means, we take the standard deviation of the population mean and divide it by the square root of m. So when we're looking at this here, this is the basis of what the central limit theorem is all about. It's about taking very large samples of the central limit theorem, or samples of a population, and then seeing what is happening as your sample size increases. And the central limit theorem will state that the larger your sample size becomes, the more normal your graph will become itself. So the central limit theorem is a very powerful concept in statistics. In our next video, we're going to do a couple of examples so you can see how we apply these in different concepts. See you then.